In this module, you will learn to find the standard deviation of grouped and ungrouped data. Let's look at the weights of 5 students. The mean of the given data is 52 and its variance is 6 kilograms. Here, it is clear that the unit of the observations and the mean is kilogram, while the unit of the variance is kilogram squared. Thus, the variance cannot give proper information about the data. In order to overcome this ambiguity, we take the positive square root of the variance, thus making the unit of the observations and the square root of the variance the same. This positive square root of the variance is called standard deviation. Standard deviation is the positive square root of the variance. It is denoted by sigma. Therefore, the standard deviation of the given data is equal to 2.449 kilograms. The standard deviation of the observations x1, x2, x3, and so on till xn is given by sigma equal to the square root of 1 divided by the number of observations multiplied by the summation of the squares of the deviations of the observations from the mean. This is the formula for the standard deviation for ungrouped data. We know that the variance sigma squared is given by the formula shown here. Let's expand the summation. On rearranging the terms and simplifying, we get x1 squared plus x2 squared plus so on till xn squared whole divided by n minus 2x bar multiplied by x1 plus x2 plus so on till xn whole divided by n plus n multiplied by x bar square whole divided by n. We know that the sum of the observations divided by the number of observations gives the mean of the observations. On simplification, we get that variance is equal to summation of xi squared divided by n minus summation of xi divided by n whole squared. Therefore, the standard deviation of an ungrouped data can also be calculated by using the formula square root of summation of xi squared divided by n minus summation of xi divided by n whole squared. We know the formula for the variance of a discrete frequency distribution. Here, the xi's are the n observations and the fi's are the frequencies of the observations. N is the total frequency and x bar is the mean of the given observations. Thus, this expression is the formula for the standard deviation of a discrete frequency distribution. The alternate formula for the standard deviation of a discrete frequency distribution is as shown. Let's find the standard deviation of the data given that has 20 observations. To find the standard deviation, we first need to find the mean of the frequency distribution. The products of the observations and their respective frequencies are 18, 60, 56 and 126. The sum of the products is 260. Therefore, the mean of the frequency distribution is 260 divided by 20, which is equal to 13. Now, the deviations of the observations from the mean are -7, -3, 1 and 5 respectively. The squares of the deviations are 49, 9, 1 and 25 respectively. The product of the squares of the deviations and their respective frequencies are 147, 54, 4 and 175 in that order. The sum of the products of the squares of the deviations and the frequencies is equal to 380. Therefore, the standard deviation is equal to the square root of 380 divided by 20. This is equal to the square root of 19, which is 4.36. Hence, the standard deviation of the given data is equal to 4.36. If the frequency distribution is continuous, then the formula for the variance is 1 divided by n multiplied by the summation of fi multiplied by the square of xi minus x bar. Here, the xi's are the mid-values of the class intervals and the fi's are the frequencies of the class intervals. Similarly, x bar is the mean of the frequency distribution and n is the total frequency. Thus, this expression is the formula for the standard deviation of a continuous frequency distribution. Let's derive an alternative formula for the standard deviation of a continuous frequency distribution. Consider the formula for the variance of a continuous distribution. On expanding the whole square, we get the step shown. Let's simplify the expression obtained. This is the alternative formula for the variance of a continuous frequency distribution. Therefore, the alternative formula for the standard deviation is obtained as shown. In this formula, note that there is no need to find the mean and deviations of the frequency distribution. The standard deviation of an arithmetic series is given by sigma equal to the modulus of the common difference multiplied by the square root of the square of the number of terms minus 1 whole divided by 12. If the standard deviation of the observations x1, x2, x3 and so on till xn is sigma and k is a constant, then the standard deviation remains the same, even if we add or subtract a constant to each of the observations. If each of the observations is multiplied by a constant, then the standard deviation is also multiplied by the same constant. If each of the observations is divided by a constant, then the standard deviation is also divided by the same constant.